These are the examples for Algebra 2B, Credit 3, Lesson 18.1. Lesson 18.1, we're going to be talking about the graphs of sine and cosine functions. And before we jump into the examples, I think we need to kind of show you guys what these graphs look like and just a little bit about what we'll be doing. So we're just going to do a quick intro here. All right, so now on the screen in a second, you should see, there we go. You should see the sine function being graphed. And so we have y equals AB sine of x. Now this a here, that's going to do what it's always done in all the other functions that we've graphed. If it's more than one, it's a vertical stretch. If it's between 0 and 1, it's a vertical compression. And if it's negative, if there's a negative in front of that, it's a reflection over the x-axis. So that's nothing new there. And we'll talk more about that as we go through the examples. Now, what is new is b. In previous classes, we've talked about there is such a thing called horizontal compression or a horizontal stretch, but we haven't dealt too much with that until now. We're going to see that with the sine and cosine functions. All right, so now let's take a look here. Notice, and this is again kind of a review, I hope. Notice we have these what we call sliders here in Desmos, a really cool feature. Notice as we make a bigger, we can see that horizontal stretch. So notice if that, well, let's go back to 1. If a is 1, notice the top of the graph is positive 1 and the bottom is negative 1. But let's say I increase that to 3. Notice that I've stretched the graph by a factor of 3. I'm going up to positive 3, and then it goes as low down here as negative 3. So now let's reset that. Well, real quick, let's also talk about a vertical compression. So now notice that a is 0.5, and that squished the graph. Notice it no longer goes up to 1. It only goes up to 0.5 or a half and down to negative 1/2 or negative 0.5. Now, let's reset that. And now let's talk about the horizontal stretch and compression. But notice what happens when I make B larger. It doesn't stretch the graph, it's squishing it. It's compressing it. And notice, now let's go back to around 1 here, positive 1. Now let's go the other way. Notice as I make B smaller, but still positive, it's stretching the graph. So here's the thing about a horizontal stretch and a horizontal compression. We have to take the reciprocal of whatever B is, and then that's going to tell us whether it's a horizontal stretch or compression, because as B got larger, it compressed. It didn't stretch. And as B got smaller, or between 0 and 1, I should say, the graph then was stretched out horizontally, sideways. And so we're going to have to take that into account. And the way we do that is before we determine whether it's a horizontal stretch or compression, since it's the opposite of what happens with A, we're going to be taking the reciprocal or flip the fraction, if you will, for B. And you'll see that in the examples. All right, so let's unshare that and let's jump into the examples. All right, so for number 1, and we can go ahead and get rid of this. So for problems 1, 2, and 3, we have this example: f of x equals 5 sine of 8x. All right, so on number 1, they're going to ask, and same thing on 4, 5, and 6, it'll be the horizontal stretch or compression, then the vertical stretch or compression, and then the period. So this is for number 1, this is for number 2, and this is for number 3, the example. All right, so for horizontal, so remember this over here is your A, this is your B. And so remember for horizontal, so B is 8, but with the horizontal stretch or compression, and that one only, we have to take the reciprocal. So we have 8, or 8 over 1, which the reciprocal, we flip it, and we have 1 over 8. Since 1 over 8 is between 0 and 1, that would be a horizontal compression by a factor of 1/8. And that's all you have to do. So in your packets there, you're going to circle whether it's a stretch or a compression, and then a factor of whatever that number you get, whatever that result is, once you do the reciprocal. And remember, for that's horizontal only. All right, now for vertical, that's our A. We've never done a reciprocal for that. We're not going to start now. So A is 5. 5 is more than 1. So that would be a vertical stretch by a factor of 5. So notice no reciprocal there. We just use what the number, whatever A is, just like we've always done. Now the period, for that, let's go back to Desmos and talk about what the period of a function is. So looking at this here, and let's just, let's leave that in there. And let's go ahead and reset these to 1. Could have just taken them out, I suppose. All right. So the period is the distance along the x-axis that the graph completes one cycle. So what's one cycle of this sine function here? So let's start here at 0. And notice it goes up and then it goes down. So we go to the top of the hill, the bottom of the valley, and then we're back to the middle. Once we get back to the middle, we've completed one period. Now you might say, well, wait a second, weren't you back to the middle here? We were, but we haven't done everything that the graph does. All we did is went up, but we didn't go down yet. So we have to do everything that the graph does, up and then down. And then when we're back to the starting point, then we've completed one period. And so the period of this sine function is 2 pi. And so without any transformations on it, without any stretching, compressing horizontally, the normal period of a sine function is 2 pi. Well, what if there are transformations? How do we figure out what the period is? Well, since the normal period is 2 pi, and B is what adjusts the graph horizontally, the rule for determining the period is 2 pi over B. So remember, B was 8, so it's 2 pi over 8. And so we can simplify this by dividing 2. 2 divided by 2 is 1, so we have 1 pi, or just pi, and 8 divided by 2 is 4. So the period is pi over 4. And let's actually see that. Let's go ahead and get rid of the sliders. I don't think we'll need those. And let's just simply put in, let's leave off the 5. Now remember, the normal period is 2 pi. And so notice here, we're going to zoom in here. And we said the period is pi over 4, or 1/4 pi. So this is half pi right here. So this would be 1/4. And notice from where it starts, it goes up and then down and back, and back to the middle. That completes one period right over here at which would be pi over 4. And you can see it there as we hover over that point where it's crossing the x-axis again. All right, so that is our examples for 1, 2, and 3. And let's go ahead and stop sharing that. And that's just so we can kind of visualize and not just do the calculation, but visualize what it is that we're doing there. All right, so let's take a look at examples for 4, 5, and 6. 4, 5, and 6, we're doing the same thing, but with a cosine function. The good news is, though, with a cosine function, the rules are the same. So starting with the horizontal stretch or compression, this is for number 4, this is for number 5 example, and this is number 6 example. So B is 1/6, but remember with B, with the horizontal stretch or compression, we have to take the reciprocal. So the reciprocal of 1/6 is 6/1, and 6/1, of course, is just 6. Since 6 is more than 1, that would be a horizontal stretch by a factor of 6. And so that's our example for number 4. For the vertical, So now the vertical, we're just looking at the number for the vertical stretch or compression. We already know that if we were to graph this, the negative creates a reflection over the x-axis, but we're just looking at the number here. So A, or the absolute value of A, I guess we should say, is equal to 1/4. 1/4 is between 0 and 1, so that would be a vertical compression. Remember, greater than 1's a stretch, between 0 and 1's a compression. And notice no reciprocal here with A. So vertical compression by a factor of 1/4. And so that is that for that one. Finally, the period is 2 pi over b. Remember, b was 1/6, so 2 pi over 1/6. Now we've got this complex fraction, a fraction within a fraction. So we have to get rid of the smaller fraction. So we're going to multiply by the 6, by the denominator to the top and bottom. 2 pi times 6 is 12 pi. Over here, the 6's cancel, so we just have 1. So 12 pi over 1, which is just 12 pi. And so our period here is 12 pi. All right, so that is that for 4, 5, and 6. All right, now for 7 and 8, let's go ahead. We got to erase all this, don't we? And let's put up an example for number 7. Number 7, they're asking us about, it says, consider the function f of x equals negative 1/4 cosine of 2x. And they ask for the horizontal stretch or compression. So we're going to get, since that's kind of the new thing, we're going to get a little bit more work with that. So here's our example for number 7. We have f of x equals negative 1/6 cosine of 12x. All right, so remember, since we're only dealing with the horizontal stretch or compression, remember this is A, this is B. And so that's the horizontal comes from whatever B is. And so B is 12 here. And remember, with horizontal, we have to take the reciprocal. So the reciprocal of 12, or 12 over 1, is 1 over 12. And so this would be, since 1/12 is between 0 and 1, that would be a horizontal compression. And they ask for the factor there. Let's fell down here. Yes, so a compression by a factor of 1/12. And so that's how you would do number 7. Number 8, it says consider the function, and then this time they're asking for the period of the function. So let's go ahead and take a look at an example for number 8. And so let's do, actually what we can do is just use the same function here. So let's go ahead and put it up, write it up over here though. Okay, so B is 12. So we have 2 pi. Well, actually, let's, you know what? Let's just do this. Let's just do X. Let's do it like that. All right, so remember the period is 2 pi over B. Now, there's nothing written here for the coefficient, but remember when there's nothing written for the coefficient, we know that it's 1. So B is 1. So we have 2 pi over 1. Anything divided by 1 is itself. So the period, 2 pi over 1, is just 2 pi. And so our period there, our example for number 8 is 2 pi. All right, so now let's move on. Last couple lessons I know have been a little bit longer, but we're almost there. There's 10 problems, or 10, is it? 12. Well, we're almost there. 8 down, 4 to go, right? All right, so let's take a look. This next graph, as we turn the page to page 30, will be for problems 9 and 10. And let's go ahead and set this up here like this. And so this will take just a second. We have 1, 2, 3, 4, 5, 6. So pi, 2 pi, Now let's actually make this a little bit. There we go. 1, 2, 3, 4, 5, 6. Kind of stretch that out a little bit. So 3 pi, 4 pi, 5 pi, and 6 pi. And then we're going to go, let's go up to maybe 1, 2, 3, 4, and then down to 1, 2, 3, 4. And let's go ahead and sketch our graph in here. And make sure we get this very carefully. And there we go. All right. So what they're asking us for a couple things here. For number 9, they're going to ask us what the period is. Of course, we know the period of a sine or cosine function is 2 pi over b, but we don't have an equation here. So we need to, let's move this over a little bit. We need to be able to determine that just by looking at the graph. So remember we said that the period is the distance along the x-axis that the graph completes one cycle. Now you might look at this and say, oh, well, here we go. There's the end of it, 6 pi. But is that one cycle? Well, let's see. We start at the top here. We go down to the bottom and then back up to the top. And that is one complete cycle. We've done everything all the way down, all the way back up. And where are we at here? We're at 3 pi. And so our period here would be 3 pi. And you say, well, why isn't it 6 pi? Well, it's doing the cycle again, because by the time we get to 6 pi, we've done 2 complete cycles, all the way down and up, all the way down and up. So that, if you said 6 pi, that would be 2 periods. And again, they just want us to give 1 period. So again, the graph completes 1 cycle between 0 and 3 pi. So the period's 3 pi. For number 10, they asked for the amplitude. This is the first time we're coming across number 10, but first time we're talking about amplitude. Amplitude is, think literally the word amplify. And so remember the sine, remember we said earlier, the sine and cosine functions top out at 1 and bottom out at -1. So that would be the amplitude of a normal sine or cosine function. Here, it's going from 3 down to -3, and so it goes as high as 3, and that's it. Our amplitude is 3. And that's all we have to do there. And so that's our examples for 9 and 10. For 11 and 12, we're going to have to put another graph up here. So again, with all of these here, I know there's a lot going on, but pause, rewind the videos as needed to make sure that you have a good understanding of what is being done in the problem. So this is our example now for 11 and 12. So let's go ahead and get this up here. And we're going to number this a little bit differently here. 1. Let's see, we'll make that work. 2, 3, we'll just extend that a little bit and go to 4. And we're going to go 1, 2, 3, 4. That's 0. And then 1, 2, 3, 4. Okay, so taking a look at our example here. Okay, we're going to start here. And we'll bottom out there. Top out there. Out there. And top out there. Okay, there we go. Perfect. All right, thank you for your patience. Of course, this is a video, so you can just fast forward through that, or so you don't have to watch while we draw the graph there. All right, so same questions here. They're asking for the period and the amplitude. So we're a little familiar with that now. So hopefully this will be a little bit even easier than 9 and 10. So the period, once again, is one complete cycle of the graph. So we start here at the top. So we go all the way down, all the way up, and we've completed one period. And where are we at? We're at 2. So our period here is 2. Now the amplitude, let's see. Well, it tops it out at 2, bottoms out at -2. So our amplitude is 2. And that's it. So amplitude, pretty easy there. Almost as easy as finding what the period of the function is. All right, so that's it for the examples for lesson 18.1. A lot going on there. But again, pause, rewind the videos, and I'm sure you're going to do great with the work. All right, so that's it for lesson 18.1. Good luck with the work, and until the next video, take care and God bless.